In this example, we're going to look at making bowls in version 9 using the new two-sided feature. We're going to start by running through a quick refresher on what's new in version 9 when it comes to creating two-sided projects. Now, when we are cutting two-sided projects, the crucial part of getting this right is to ensure that you have exact alignment in X and Y when flipping the material over. So I'm going to briefly talk about how you can use dowels to ensure that we have a fail-safe way of aligning the parts when we ultimately flip the part over. Then we're going to jump into a session of V-Carve, and we're going to look at how we can assemble a bowl to cut as a two-sided project. And then to follow this video, there are two separate videos that cover how to use the new spin tool in Aspire to create a spun bowl. And finally, a video on how to model a leaf bowl, also in Aspire. So let's have a look at the all-important new features that have been added to version 9 that are specific to two-sided machining. And when you start a new session in the software, within your job setup form, you now have the option to select between a single-sided and a double-sided job. To create a two-sided part, you want to select double-sided. And then you'd go ahead and set up your job size as normal. The Z0 position can be selected for both sides within the job setup form. So as normal, we can set that from the material surface, the machine bed, or we could zero off the same side so we're referencing from the same face. Then we choose which way we'd like to flip our material over, so we can flip that from left to right, or we could flip that from bottom to top. And then once we've entered all of the information within the job setup form, we'll then enter a new session. And so it will look something like this. So here we have the option to switch between the top and the bottom, and if I click on that toggle button, you'll see that I'm now able to switch between the top and the bottom sides. In the 2D view, the bottom is represented with an orange ruler, just so I know that I'm on the bottom side. And then we have the option over on the right hand side to visualize our part in a multi-sided view. So when we click on this option here, I'm able to view both the top and the bottom in the same session within the 3D view. So not only can I see the top and the bottom of components that I've assembled or modelled, but I'm also able to visualise the toolpath preview, both the top and bottom within the 3D view there. Over into the 2D view, whilst we're in a multi-sided view, we're also able to visualise vectors that may be on the other side. And all of this is very useful in that we're able to see everything that's going on both sides in one single session, so we're not left to do any guesswork. And all of this will be covered throughout the different examples that we'll be looking at throughout this tutorial and the two separate bowls that we'll look at separately. When creating a two-sided part, it's crucial that we have exact alignment between both sides in terms of their X and Y locations. And there are many methods of doing this, but I'm going to go with a method that I know is pretty fail-safe, and that's using dowel holes positioned in a random asymmetric manner. So what do I mean? So let's say that you have your part in the job. You need to draw circles that are the same diameter as the dowels that you plan to use, and then randomly position them around your part like so. Then you're going to take your dowels and you're going to select all of them, where you'll use the right click option to copy to the other side. And so when you flip the part over in the software to view the bottom side, you will see that the dowels have been positioned according to your flip direction that you set up in the job setup form. And so there we have everything we need. We can begin to run the toolpaths. So your first operation here is to take the dowel vectors for the top side and partially cut into the top side of the material block. And then we can then run the other toolpaths that you have for this side. In our example, we have 3D toolpaths cutting a ball. And so at this stage, that's everything cut for the top side. Now we have two options here. We could resume and cut the bottom side set of toolpaths, or we could turn off the machine and cut the bottom side another day, as the way that we've set up our dowels enables us to do this. Let's say we take advantage of the fact that we can turn the machine off and cut the bottom side the next day. Then your first operation here is to set your X0, Y0 position on your machine, and then you're going to take the dowel vectors for the bottom side and you're going to machine directly into the spoil board. These dowel holes are now your location holes. And so taking the material block, we're going to insert the dowels into the dowel holes on the top side that we cut yesterday. And then we're going to flip our material block over and we're going to locate those dowels into the holes on the bottom side that are in the spoil board. And here we have perfect alignment. And the fact that the dowels are positioned in a random asymmetric way means that there's only one possible way for us to locate the part. So then we'd secure our part in place using screws or clamps, and then we'd simply run the other toolpaths for the bottom side. And so the benefits of using this asymmetrical dowel method means that I can cut our part in two separate operations, especially when we're dealing with 3D machining. 3D machining in a single-sided job can take quite a while to cut, and so having the ability to cut in two separate operations just makes life a little bit easier for me. It is also pretty fail-safe, as there's only one possible way that we could locate our part, and so we don't get confused with which way we flipped our part over, whether that was in the horizontal or the vertical, as our asymmetrical random positioning of the dowels means there's only one way that we could ever locate the part. So let's have a look at an example where we create a two-sided bowl in V-Carve. Here we're going to make use of the free Clipart that comes with V-Carve and assemble the Clipart to make a full 3D two-sided bowl that you can see here. We'll look at how to add tabs to hold the bowl in place and run through the toolpaths to cut the part out. We'll then discuss how we could remove the cusping effect that may be left around the part due to the fact that we are using a round tool to finish the part, where only the centre of the tool will ever touch at 0. And so we'll look at how we can create and utilise a limit plane with a negative base height to drop the finished tool below 0 to ensure that the cusping is removed. And then to finish, we're going to look at alternate designs. So in the software, we're going to go and create a new file. So working with a double-sided job, here we're going to enter our job dimensions. So working with 10 inches for the width, height is going to be 10 inches, and our material thickness is 2 inches. I'm going to set the Z0 position of the material surface for the top side. For the bottom side, I'd like to set our Z0 to the machine bed, so I'm going to 0 off the same side, so we're referencing from the same face. XY datum position is in the lower left hand corner. We're going to flip that across the horizontal there, and then we could go ahead and press OK. So I'm going to go straight to the modelling tab, just to organise my levels in advance. I'm just going to right click, rename that level. We're going to call this level the model level. And then we're going to go into our Clipart tab, and I'm just going to locate my Clipart. So I'm looking at all of the Clipart that comes with V-Carve here, and I've got a section here called domes and dishes. So here I've got a variety of different domes, all at different angles. I'm going to take this one, 45-degree angle here, double click that to bring that into the centre of my job, and then I'm roughly just going to size that up. Okay, you might want to make that a little bit bigger. Okay, something like that looks okay. Let's just tile our windows so we can see the part there in the 3D view. And then now I'd like to create the sort of recessed area of our dish. So this time I'm going to look at using another dome but with a steeper angle. So we're going to look at this 90-degree dome dish. So let's just double click on that. That's going to automatically put that into the center, and then we're just going to roughly position that. Okay, that might be a little bit too small. Something like that seems okay. And if you just go into the modeling tab, we're going to alter the combine mode of this component. We're going to set it to subtract, so it's subtracting into our overall dome shape there. So with that component selected, let's go into the properties. I'm just going to reduce this. It's a little too deep at the moment, so I'm going to set that to be 1.8. Press the space bar to enter that in, and we can see that has applied there. So we'll just put that in the Z, and then we're going to close out of the dome dish properties there. And so that is pretty much the model complete. So what we need to do now is position our dowel vectors. So if we go into the drawing tab, we're going to draw a circle, and I'm going to use the transform keys. So I'm just going to drag to begin drawing a circle, and I've measured my dowels and they are 0.33 of an inch. So I'm going to type in 0.33 and then D on the keyboard for diameter, and it'll instantly create that for me. So just position there, and now that I've entered that in, the form has already updated, so I can just go around now and just click in position for the other dowels. Okay, so that's okay. We can close that down, and we've got our dowels in place, and that's pretty much the top side done. Now I want to take a copy of the larger dome that we've used for the top side of the bowl and send that over to the other side. I also need to send a copy of our dowels over to the other side also. So if that's selected, I'm going to hold down Shift to select the other two dowels, and Shift still held down, I'm going to select on the larger of the two domes. Then we're going to right mouse click and use this option here to copy to the other side. That's going to send those vectors along with that component over to the bottom side. And so now when I come over to toggle between the top and bottom, if I click on that, I can see we're now on the bottom because my ruler is displayed as orange, and there's an arrow pointing at the bottom side of my material block there. I can see my dowel positions have been mirrored over, and I have my component there. We are looking at this in a multi-sided view, so when I come into the 3D view, I can see the whole part, and I can see everything is aligned correctly, and that's because the software has done that for me when we copied everything over to the other side, and it's done that based on the flip direction going from left to right. So let's just put that in Z. Let's go into the modeling tab again to keep organized. I'm going to right click and rename that level. We're going to call this level model. And if we take a look at our model, if I just go to view, just temporarily draw that modeling plane so we could visualize our part as if it was actually sat on, say, a countertop, we'd see that our bowl will just constantly be wobbling around because it has no flat bottom. So I need to implement something that's going to have a flat area in the bottom side of our bowl. So to do that, let's just go back into our Clipart tab, and we can see here that I have a flat round circle within the domes and dishes section. I want to double click to bring that in. And it will again put that into the center. Just going to make that a little bit smaller, like so. And we can see it's currently being obscured by the height of the big underside dome of our bowl here. So what we need to do is we need to just look at the properties there. So with that component selected, go into the properties, and then we're just going to adjust the base height. So if I just run my cursor over this area, over here I can see it's currently at 1.2. So let's have a look if we add in a base height of 1 inch in there, press enter to enter that in. We can see that's just about coming through, so let's try 1.2, and there we have a nice flat bottom there. And so now when my bowl is sat down on a side, it's just going to sit nice and flat thanks to this flat bottom that we've just added there. So we're almost ready to go to the toolpath side of things. Before we do that, we need to ensure that our bowl is going to be held securely to our material whilst we're cutting both sides. And so to do that, we're going to look at adding in 3D tabs. So let's go over to our component tree. I'm going to right click on the model level. We're going to insert a new level. Right click on that level. We're going to rename this one. We're going to call this one tabs. And then we're going to right click, set the combine mode of this to merge, so any tabs that I add into this level will blend in with the actual composite model that we've got here. Let's go to our Clipart tab. We have a folder dedicated for 3D tabs. You'll see we've got 3 new pieces of Clipart, and we've got this underscore rectangular one. I'm going to double click that to bring that in. So it's just a rectangular tab. I position that along the centre at the top there, and if we go into the 3D view, we can see that tab. We can check the height of that, 1/4 inch. That seems pretty reasonable in this case. I'm just going to drop that down a little. Okay, that's okay. So now we could look at adding more tabs. I could just go in and position them, or I could just let the software do that for me by selecting that component there, and then we're going to go into the drawing tab. I'm going to use the circular copy tool. Okay, we're going to make sure that our rotation center is in the center of our job. So if we take a look, when I double click on the center here, you'll see that rotation center has been pulled up to the center of our job, and our part will be rotated about this point. We want 4 copies, and we want to rotate those copies, and then we'll group them once we've created those copies. So let's press copy, and there are the 3 other tabs that have been positioned around the outside of our bowl. If we go into the modern tab, we can see that they've been grouped because we chose to do so in that form. So now we have everything set up ready for us to run our toolpaths. So let's switch back to the top side, and then we're just going to switch over to the Toolpaths tab. So first and most important, we want to go into our material setup. So here we just want to check over a few things. Material thickness is 2 inches, XY datum position is going to be set to the lower left hand corner. We're going to set the Z0 on the material surface for the top side. Model position in the material, you can see we currently have an error in that our model thickness actually exceeds our material thickness. So we're just going to tweak that. I do have a little bit of room just to shrink that down, and I'm sure that it won't cause too much of a change in terms of the way that our bowl looks. So let's use the set option there. Here I'm just going to go for 1.8, press apply, and then we'll just simply close that down, and it's been updated there. And then I'm going to position the model in the material so it's in the dead center of our material. That way we have material above and below, so this can just account for any discrepancies in the actual thickness of our material there. Check over your rapid Z gaps above the material, clearance plunge in your home and start position, and then once I'm happy with everything, I'll press OK. And so your first operation here is to take the vectors that represent the dowel holes. I'm going to go into the profile toolpath. We're going to cut partially into the top of our material block. So here we're going to have a start depth at 0, the top of the block, and I'm going to cut down, say, 3/4 inch into our material block there. I'm going to use a 1/4 inch end mill in this case. I'm going to select the 1/4 inch end mill, press OK. I'm going to machine on the inside of those vectors, and then we're just going to give that a name. We'll just call that one Profile Dowels. Simply press calculate, preview that, and we can see those dowels in position there. Okay, let's just close that down. Then what we're going to do is we're now going to look at our 3D toolpaths. So we're going to go into the 3D roughing toolpath here. I'm going to use the 1/4 inch end mill. You can use the edit option just to check over the settings in there, ensuring that they're safe and appropriate. Then we move on to the machining limit boundary. In this case, I'm going to select the model boundary. So the tool will take a look at the model that it can see and use that as its boundary to define the actual roughing toolpath. I'm going to put a little offset in there, same diameter as the tool, so it comes past the edge of the part by this amount, so 1/4 inch. Machine allowance will go with 0.03 in this case, so just a tiny little bit of skin will be left on our part for our finish tool to come out and finish that up. Roughing strategy, we're just going to do a basic Z-level strategy where we're going to raster in the X-axis, and then we could just give that a name and we'll call that one 3D roughing. Press calculate. The software will just calculate that for us, and then we could go ahead and preview that part and we can see all of those steps there. Okay, so that looks pretty good. So we've hogged out all of the large parts, and now we could use a smaller tool to get in at all of the finer, smooth detail that we can see here. So let's go into the 3D finishing toolpath. So here we're going to use an 1/8 inch ball nose. I'm going to use the edit options to check over the settings there. Okay, step over of 8 to 10% seems reasonable. You go ahead and press OK. And here again we're going to go with the model boundary. I'm going to go with an offset, again using the same diameter as the tool that I'm using here. I'm going to apply an offset strategy as it's a rounded shape. I'm just going to go round and then it will move on to the next contour and go round again. So as I'm using that offset strategy, I'm going to help myself by adding in a step over retract of 0.02, and that will help eliminate the tool markings as the tool travels from one contour to another. The tool actually lift, then travel to the next contour and drop down. So it won't create the tool marking line that you commonly see when using the offset tool on rounded parts. So here we're going to give that a name. We'll call that one 3D finish, and then we could simply press calculate there, and the software will just take a moment to calculate that for us, and then we could go ahead and simply preview that in the preview toolpaths form. Perfect. Okay, so I like what we've got there. We've got a nice dish in there, and we can see how our part would look if we was to cut that out on our CNC machine. So now we can switch over to the bottom side. So let's come over here. We'll just close out of the toolpath preview. We're going to go to the bottom side, and you'll see now that we can enter in toolpaths for the bottom side. So as always, again, let's just have a glance over our material setup. I can see straight away that our Z0 has changed, and it's now Z0ing off the machine bed, and that's because I set that up to do so in the job setup form right at the start of our job, and that just always ensures that I'm referencing from the same face that we've just cut from. Okay, so we've got thickness, XY looks correct, model position it's still in the centre there, perfect, and then everything else looks okay here, so just checking over just to ensure everything looks correct there. So for our first operation we're going to take those dowel holes, okay, and what we're going to do here is, well, what we would have done is took our material block off of our machine bed, and now our first operation here is to run the dowel holes for the bottom side directly into the spoil board so that we can create our location holes for when we flip our material over to ensure that we have correct alignment within our X and Y positions. So with those vectors we're going to go into the profile toolpath form. The start depth for this, I'm actually going to enter in our material thickness, okay, so the tool is going to drop down by the thickness of our material, and that should reach the spoil board, and then we can cut into the spoil board, and we're going to cut in by 1/4 inch this time, so 1/4 inch into the spoil board. We're going to use a 1/4 inch end mill and a machine on the inside here, and then we'll give that a name. We're going to call this one profile dowels, and then just to remind myself, spoil board only, so we're not cutting into our material block here. Press calculate. Software is going to warn me that we will cut through our spoil board. That's okay, that's what I intend to do, so I'll go ahead and press OK. And just so you can see what's happening here, we can see tools coming over. It's going to drop down to 2 inches, which is the material thickness, though we're not going to have our material thickness in place there. And then it's just going to cut in 1/4 of an inch. Okay, so we're not actually going to preview that because we're not going to cut into our material block. This will be cut into our spoil board. So let's just close that down, and then we'll just undraw the visibility of the profile dowels toolpath. And now we can look at running our 3D toolpaths. Let's go into the 3D roughing toolpath. So here again we're going to use a 1/4 inch end mill. Machining limit boundary, we're not actually going to select the model boundary this time. If we did that, let's just take a look. So just calculate that and then preview that. You'll see that we'll actually cut our tabs out of our material block. We don't want to do that. We need to keep our tabs intact to our material block to hold our bowl in place. So let's just use the undo last option. I'm going to go back into the roughing toolpath, and this time we're going to look at using the selected level. So if I just open up the modelling tab over on the left here, you'll see we have a level called model that has our bowl in place, and then we've got a level called tabs. So what we can do here is specify to use this selected level. We want to use the model level as our boundary. So it's going to take all the components within this level and it's going to use those components as the boundary for our toolpath. What it also does, it will then accommodate any models that lie within that boundary. So for instance, it will include the tabs that we've got here, and that will ensure that we don't cut the tabs away. So using the selected level for the model, so we're looking at these components here, and put in an offset so it cuts past the part by 1/4 of an inch. So you're going to see the toolpath cut past the bowl by 1/4 of an inch, so we're going to see quite a bit of our tab sticking out there before it goes into our block of material. Machine allowance 0.03, and we'll do a Z-level strategy. We'll call this one 3D roughing and press calculate, and we'll just move that over so we can see that, and then we can preview that toolpath, and you can see straight away that our tabs are still connected to our block of material thanks to the option to use the level as our machine boundary. Perfect, so let's close that down. We're going to go into the 3D finish pass. We use an 1/8 inch ball nose in this case. Again, we're going to use the selected level, the model level, with an offset so it rolls past the part. And use an offset strategy, and again we'd like to apply a step over retract of 0.02. Call that 3D finish, press calculate. And it's just going to take a moment to calculate that for us. And then it will open up the preview toolpath form. We can preview that toolpath and we can see the result of that finished pass, and we can see our tabs are still held securely into our block of material so the bowl won't fall out. And so let's maximise the 3D view, and we'll just take a look at our part so we can see the two sides, and we can see we're not actually cutting all the way through, and what we're actually seeing here is the result of the fact that we are using a rounded tool to cut our part out, and only the centre of this rounded tool will only ever reach 0. So we will be left with what we call this cusping effect, or a seam that you'll be presented with around your part. So to eliminate that, what we could do is look at applying a limit plane where we could drop the tool down past 0 to ensure that we cut away at the cusping. So let's just put that in Z, and we're just going to switch back over to our modelling tab over here, and within the model level I'm going to right click to insert a new level. I'm going to right click to rename that level. I'm going to call this one Limit Plane. I'm going to set the combine mode of this to merge. So go to the combine mode, set it to merge, and then I'm going to create a zero plane that's going to sit there. It's going to quickly come over to the toolpaths over here and close out of the toolpath preview there. And then with our zero plane in place, I'm going to go into the properties and I'm going to look at the base height. So here I'm just going to drop the base height here down by, say, the diameter of the ball nose that I'm using, so 1/8 of an inch there. And we'll close that down. Okay, so now that we've got a zero plane that goes below 0, when I come to recalculate my finish pass, what it will do, it will accommodate that new plane and the tool will drop down past 0 by 1/8 of an inch, and we should see that we actually cut through there. So if we preview that, you can see we're actually cutting through our part, and that will eliminate the cusping effect that we may have on the edge of our two-sided part. And there is our finished bowl. So let's just put that back in the Z view. And so what we've created there is quite a basic bowl using the Clipart that comes with the software. We could look at alternate designs for our bowl. For example, we go to our Clipart tab on the top, and we could go into the decorative section or even the weave section, and here you can see that I've got a series of circular weaves. I could double click on one of those, and that will bring that into the center, and I could just bring that out like so into the modeling tab. Could set the combine mode of that to add, and there we have a nice woven pattern that we could then go ahead and recalculate our toolpaths to include that pattern there. So that's one idea. Another idea is to look at applying a texture toolpath to the rim or the edge of the top surface of our bowl. So let's have a look at a technique that will enable us to use a texture toolpath to go around the edge rim of our bowl. So just going to go and tile our windows. I'm going to go into the drawing tab and I'm just going to draw a circle. I'm going to find the centre point of my job. I'm just going to roughly sketch in a circle. Just click on the actual grayscale so I can see where that is. Okay, that's not too bad. I might make that a little bit bigger. And we're just going to bring that out, and then I'm just going to simply offset that outwards by 1/8 of an inch, and we're going to use the select new option every time. I'm just going to offset that out so it covers the majority of the rim there. Perfect, so let's close that down and take all of those vectors and go back over to the toolpaths tab. I'm going to go into the texturing toolpath. So here we're going to select our ball nose. We're going to go with an 1/8 inch ball nose in here. Could use a V-bit if I wanted to. I'm going to use the selected vectors as a pattern and just go with some of these random settings here. So max cut depth of 0.2, minimum depth of 0.1. And I'm going to make sure that I project that toolpath onto our 3D model there so it follows the contours of the actual bowl. I could go ahead and calculate that, and then we could preview that toolpath, and we can see that we've just got a very basic part there. It doesn't look too bad. It's not really the effect that I was after, but it does look quite nice, and I could go ahead and cut that as a different variation. The effect that I was looking for was more of a varied effect where the tool would drop in and out, going all the way around the vector. Now, in order for me to do that, I actually need to break up these vectors into lots of individual vectors. Okay, so let's have a look at how we'd do that. So we'll just close out of the toolpath preview there, and we'll just come over, and here, if I just take one of those vectors, and if we go into the node edit mode, you can see that this vector is made up of 4 spans. Now I like to add in lots more nodes into each of these circles and then break each of those nodes up, so we're left with lots of little tiny spans that we could then apply to the texture toolpath so we can create variation in the actual texture itself. So one way of doing this, and an interesting way, is to take all of the vectors there, and we're going to use this option here to fit curves to selected vectors. And normally we only ever use this to smooth out our vectors by using the Bezier curves option. Well, in this case we're actually going to choose the fitting type to be straight lines. So we're going to want to create lots of straight lines within each of these vectors. I'm going to use the option to replace the selected vectors, preview that, and we can see we've got lots of different straight line spans there. Perfect, that's exactly what I want. And so now I need to cut them up. So if I go to Node Edit, I could go in and individually cut each one of those nodes, but that's going to take me ages. What I could do instead is look at the new gadget that was added to version 9, and I'll select all of those vectors, go into my gadgets, and here we're going to go to the Explode Vectors option. Now if you are using V-Carve Desktop, you won't have access to any of the gadgets here, so this is purely a V-Carve Pro and Aspire only feature. We're going to use the Explode Vectors gadget, and that's essentially going to explode those vectors up into their individual spans. So here we're going to replace the currently selected vectors. Check, we want that checked, and we want to put them all on a brand new layer, and the layer name will be called Exploded Vectors by default. So let's go ahead and press OK, and now you can see that when I select each one of those areas on the circles, we actually have lots and lots of different individual spans, and that's exactly what I need there to run my texture toolpath. So let's just go and switch over to the Toolpaths tab, and we're going to go into the texture toolpath. I can see that all of my vectors are selected here. I can simply go ahead and calculate those, preview that, and you can see we've got much more variation there. I like the look of the part, that looks pretty neat. Okay, so that's just another way that you could essentially decorate the bowl if you was creating this. So let's go ahead and save this file. So go to File, Save As, and in the project folder for making bowls, we're going to call this one V-Carve Bowl, and then simply press Save, and you can access that from the project folder. As I say at the start, there are 2 extra tutorials that cover how to model a bowl in Aspire using the spin tool and how to model a leaf bowl. So thank you for watching.